Hello everyone, last week we did the initial setup. Today we'll look at the basic flow of RAG. So let me walk you through. So last time we set up this quadrant DB. Today you can see, last time it was empty. Today you can see the points 10, segments 5, stars 1. This, to know what these numbers are, you need to dig deeper with quadrant DB, vector DB, right? I'll just let you know 10 points means there are 10 document here. So if I click the RAG, so now you can look at this 10 information saved. I'll show you in the code what loaded this one. Last week there was no information. Today we loaded this information here in the DB. So there are a lot of information here. You can go to graph. It shows the 5 dimension. It broke the data into, there will be millions, but it just shows 5 because that's what we can consume, that's what we can understand. So if you click similarities, right, so let's do LLM. So it brings all the LLM related information first. Let's say this one. If I do this one, so it brings, so that's how it knows how to answer the question based on the user input. And if you want to look at the graph, this is the 5 dimensions, right? 1 2 3 4 5. So let me show you a demo in the Postman. I prepared one endpoints with 2 different scenarios, use cases, right? Relevant question, tell me about RAG. So it gave the answer. RAG is retrieval augmented generation, is a technique in natural language processing that combines this information. And I'm going to ask it a relevant question, right? Tell me about Mars. It says I don't know. So I have header, this is the user, just to have the memory that we did a few weeks ago, last week. Basically this is the basic setup. The flow is, I'll show you in the code. So the basic setup or understanding for RAG is load the document first, right? So I created document. I have a text based document for now, but you can load from DBs, you can load from all the logs or PDFs or Word document, any kind of documents. So I created a component called data loader here. I have a text, I created dummy text. So post construct is for whenever the bin is being initialized, that's when this gets loaded. This is for demo purpose, but you can load the data based on your own business requirements, like schedule it once a month or at certain time, that's business use cases. So this is, the data is streamed in and mapped into document, right? Each data, so the 10, right? 1 2 3 4 5 6 7 8 9 10, that's the 10 documents. So for each information, it created each document and then added to the vector store. So this is the vector store. This is what puts the data into the quadrant database. So first is loading, then then it's normal process. Create controller. So this takes in user name in the header and the prompt. So this also would be based on your use case. Then I have a chat client. So I have prompt template. So this, if I go here, this is how it knows when to answer and not, right? So this is the context for it. This is the documentation gotten from the quadrant DB, and this is the instruction. So if it does not know, say don't know this, you can improve based on your requirement. So what it does is, when it gets the prompt and a username, what it does, based on the given prompt, it queries the top 3, because we don't want a lot of document. As you saw in when I did the similarity search, right? As you go below, as much as informations are there, it starts becoming irrelevant. So this is your use cases. You can do 5, 3, as much as you want. So I am getting the top 3 relevant information here. Once I form the request, I'm sending it to the similarity search to the vector DB that we stored the information in, right? I have couple of logs too, just to get to know. And then once I retrieve the message or the information, I'm trying to collect it and put it in one string. After that, I'm passing the information. This is prompt templating. If you remember, we already did prompt templating stuff. So I'm passing the template, and there the documents, right? Here I have the documents. So this needs to match documents that would be filled with this mapped results. So now it has that context. Then advisors are for conversation. This is for chat memory that we configured in the config. This is nothing new here, advisors and chat memory for that. Then we are sending the prompt and then making the call. That's the whole flow. Again, controller calls service. Service makes the business use cases and then returns it. So it's not difficult. The only thing we need to remember is when it comes to RAG, we need to load the data, store it in the vector database, and retrieve the relevant information from the vector database. So one more thing I want to show you from here. If you copy the vector, this information, and put it here, right? Let's do this one. Look at this. So this is what it does. When you store the document in the vector DB, it turns it into vectors, vector information. And then how does it know how to find the relevant information is based on this one. So it breaks the question into similar vector. Then it tries to find what are the similar to or close to these numbers. That's how it tries to find the similar information. If you want to learn more, you can look into something called cosine similarity, like cosine similarity. That's how it tries to find. Cosine similarity is a metric used to determine how similar two non-zero vectors are. So if you want to know more, that's math behind how it tries to find the similar data. So that's all for today. We'll do a little bit different type of similar RAG flow next week. Bye.